Hello, Shreyas and all. So you guys are able to hear me, right? My video is my video and audio, everything is clear, right? Okay. If you have any issues, like stop me, you can raise your hands. Then uh, like we can you can ask your questions and all. So I am Avinash Padi. Currently, I am pursuing my PhD in the Department of Chemical Science at IISER, Kolkata. So, and I have been selected as a PMRA fellow. And pursuing my PhD at IISER. So, as per the PMRF and PTL agreement, so I have to do the live sessions, uh, and as a part of TAing this course in the chemical process intensification. So you can see the like so probably we can start with some interaction. Like let me so you guys can turn on your mic and say something about the course that like how is it and whether you guys are liking it or not. So the videos and all from the instructor Professor Subrat Majumdar, SK Majumdar, it's been all there. And the week two contents are also live, right? Okay, so you guys have gone through the lectures. Okay. Okay, so have you tried to solve the assignment? Yeah, yeah, it was actually not problem based. It's actually okay, Shreyas, that's fine. You can type your message in the chat box. Whom is anyway interacting. So, so like actually we have like previously also this course has been done. So there are a few sample questions or previous assignments you can say. So like that I will be discussing with you guys. Okay, so we'll go through the questions of the previous assignments so that it will help you guys to solve the recent assignments of this course. Okay, so this is the okay. Yeah. No, no, no. In future, like numericals and the problems will come. Okay, but for like as this is one like massive open online course, so like everything has to be systematic, right? So history, philosophy, and every part needs to be there. So that's why the lectures are being made in that manner. So everything will come. Like just go through the week contents and you will get everything. Okay, and there are official TS also. Probably you guys have like interacted with them or some sort of connection or contact has been done, right? Or home. So like have you guys met or interacted with any of the official TS yet? Okay, okay. Actually, to inform you, like I'm not the official TA for this course. Okay, so as a part of my PMRF deliverables, I have to do this live sessions. So, like in normal NPTEL courses, there are only pre-recorded videos which are there. So, you guys like every week there will be contents releasing, and you guys will be able to like register and go through the contents. So but this is one live session that is been like the you guys are getting the opportunity to like just interact with and with one of our like one of the TAs and like getting to know about the course better and all. So this is the new initiative that NPTEL has it has started. So okay. So let's start today's session. So I'll be sharing my screen and I'll be showing the some model questions or previous assignments. You can say who our TS is. Uh, Actually, Shreyas, you can like in the online NPTEL course portal itself, you can get to know about the official TS. There are tutors. A section is there, tutors. So you can go there and uh, I don't know the names, but there are tutors. You can get that section in the online. You can get it online in the course portal. Okay, so try finding it out. Otherwise, write it to me or the instructors. They will help you. Okay. Okay. So let me show you. So the course is chemical process intensification. It has been run by instructor Professor S.K. Mazumdar from IIT Guwahati, and I am Mr. Avinash Pathi from IISA Kolkata. So this is some like model questions for you guys. Like the first one is like process intensification can also be called as. There are four options: A, process control, process dynamics, process improvement, and process equipment designing. Okay, four. So like Shreyas and Om, can you guys try like which one could be could be a correct answer? Yeah, it is. So process improvement, very good. So like it is. This is basic like how like uh, it is about intensifying a process. Intensifying means so the basic needs that are there, basic requirements, like modifying them in certain way so that the whole process improvises. Okay, so this is process improvement. So can I get to know your backgrounds like Om and Shreyas, uh, like BSc you have done or okay, okay. Final year, in a final year. Fourth year will be final year, right? Okay. And Shreyas, I think he'll be typing his message. Okay. Okay. So you guys are from same college, BMS. Okay, you are from RB and he is from BMS. Okay. The third year and he is second year. Okay, cool. So okay, let's move. So this was the like first question you can say like first one. So the second one is based on British disciplines of process intensification, which of the following was where the primary area of interest? So, Sir has mostly told you in the first lecture in the history that like the whole history of how it has been, how the research has been progressed from the British, from the Americans, from the French, from the Holland. Okay, so like uh, could you guys try like which of the following was where the primary area of interest? So the options are intense mixing, compact heat transfer, use of centrifugal forces, and all of the above. Okay, all of the above sounds good, right? Okay, so okay, Shreyas has also answered, and yeah, it is all of the above. So intense mixing is the one. What is it is required to like to like proper mixing of the reactants if happens, then only uh, the reaction time can be minimized, the yields can be improvised, right? So intense mixing inside the reactors is one important criteria. Then also compact heat exchange, so for which there are compact heat exchangers like thin films are there, uh, channelized pipes are there, okay, and use of the centrifugal force for so that during mixing if some intense mixing happens, also that if some impurity has been found, then it can be discarded. So all of these are like parts of or disciplines of process intensification. So going next, there is like triple P triangle. Okay, process intensification was the highest rated activity of DSM within the known triple P triangle. So which one of the following cannot be drawn under the triple P? Okay, so there are three P's which are like uh, which are the necessities of this process intensification, you can say. So which is asking that which one of the following can't be drawn under the triple P, that is profit, planning, planet and people. Which one? Home. uh, oh, processes are actually meant for the people, right? For the benefit of them. So people are the, they are the ones. That be actually the question has asked that which is not drawn under the triple P. Okay, so planet. Yeah. Okay, let me see if, okay, confused, right? So it is actually like planning. So actually planning is the correct answer. So this is the triangle, right? Every process needs to have the profit. Okay, profit needs to be there, otherwise how will the industry work? Okay, the industry won't sustain, right? Then it needs to be sustainable and greener for the planet. Okay, because it is the place where we live, and this is meant for the people. The people are, they are the, these are the ones which are benefited mostly. So and planning is something which is, which goes in the process itself. Okay, so like the designing and other stuff is that goes in the, goes within the process itself. So that's why the triple P triangle is all about profit, planet and people. Okay, so next, this in this has been discussed in sir's lecture, that the famous onion skin methodology of development, right? So there is a chart which he was showing in the slides. So can you guys say that which one is not included in that? That is commercial valuation, heat integration, separation and safety. Commercial valuation, right? Okay, right answer. So this is another onion skin where like the reactors in which it is reacting, then the separation and recycle happens, heat exchanger network is there, and then the utility starts to happen. Okay. Yeah, Shreyas has also answered correctly. So is there any way that I can, while presenting, I can see at the chat box or something? Because every time I have to, yeah, it is there, but while presenting I am not been able to see the chat box what Shreyas is typing. Okay, let me do like this. still visible, right? But when full screen it is going back. Okay, that's fine. So I can be going back and forth. Okay. So the fifth one is like select generic principles of process intensification from the followings. That is, optimize the driving forces and resistances at every scale. Maximize the synergistic effect from partial process. And C, minimize the synergistic effect from partial process. D, all of the above. Uh, Actually, there is one mistake in this question. Yeah, A and B are actually correct. So C shall not be there. Uh, there is some typographical error in this. Correct answer, if A and B, then, and if we exclude C, then it will be all of the above. Or actually, both A and B are correct. Right. Okay. So going next. So process intensification is a term used to describe the strategy of enhancing the scope of chemical plant needed to achieve a given production objective. So it is a term that is used to describe the strategy of enhancing the scope of chemical plant. Is it needed to achieve a given production objective? Actually, it is to improvise the process or some operation which is already there, but to achieve a given production objective. So, enhancing the scope of the chemical plant. Actually, in process intensification, it is not only about the production. Okay, there are other aspects of it, like how we need to improvise it, and uh, like besides or in addition to the profit or the production, what are the other things that we need to keep in mind? So production can't only be an aspect, so it is actually false. Then which one of the following is not a triplet feature? Triplet feature, like process calculation, molecular process, product, process engineering. This was also shown in the slides of sir, that the triplet feature he has discussed about this. Yeah, it is. Yeah, correct answers. Process calculation is not a triplet feature. Actually, this molecular process, product, and process engineering, this is the slide I was talking about which sir has shown. Okay, this is the triplet feature. Okay. But you have been able to answer these questions, right? These are basics. So like Shreyas might be in his second year, so but he has also answered all the questions right. Right. So you guys have, like, as you guys are studying in the chemical engineering, so this is some basics that you must have already known. Okay. So then course is like will be going smooth. So don't worry. So next is, which of the following is are the examples of principal features? That is convective heat transfer phenomena in spinning disk reactor, formation of urea via dehydration of ammonium carbonate, separation of carboxylic acids from wastewater via reactive extraction, or D, all of them. Yeah, it is correct. So actually, like in the principal features, like how the reaction proceeds. So how can we improvise the intensive mixing? How can we do the ultrasonic waves? Apply the ultrasonic waves or the centrifugal forces. All of these are important. So like heat transfer, like how it can be compact. Okay, so these are very like few examples in which all the features is been applied to. Okay, so the answer will be all of them. So Next one is ultrasound has a critical impact on the process due to which of the following? That is, A. Restrict the development of free radicals, create a lower surface area, waves generate intense mixing condition, and wave cannot propagate through a liquid medium. So, which one is the critical impact that a ultrasound wave plays? Yeah. So, it is actually to generate the intense mixing condition. So, uh, like the reaction or the reaction time or the feasibility of the reaction, it depends on the like how well the reactants or the components mix. So how the retention time through the micro reactor, if it is flowing, then how well it is getting mixed. That is, uh, so from the kinetic theory of these reactions, if we can if you guys know about it, that two reactants, they collide together or meet each other, then only the reaction happens. Okay, so this mixing process is very important for uh, the process to be sustainable or feasible. Okay, so that's why this ultrasound waves is being applied. Okay, so that the every component gets proper time inside the reactor, and they meet each other properly, so that the reaction completes to like 100% conversion, giving very good yield, and also better separation and other extraction. These are the things. So the next question is, the effectivity of microwave can be improved by increasing dash, the reaction time, rate of reaction, irregular heating, or none of the above. The effect of microwave, now actually nowadays actually microwave is been applied for certain reactions, like likewise temperature, or like in some chemical processes we apply heat. Okay, we apply mechanical forces, some, and so microwave is nowadays is been, it is been utilizing, people are using it. So how can it be improved? Can you try one? Not sure. Okay. Shreyas, let me see. Okay, reaction time. Okay, it's actually correct. The reaction time is the answer. So like microwave is been used to improve the rate of the reaction. If we there is no impact of like there won't be any impact on the microwave if we increase the rate of the reaction. So B is false, and irregular heating can't be done in the microwave. Microwaves are, it is been irradiated and some heating is been created. Okay, heat energy is been created. So if we give more time, the reaction time, if we enhance, then the effectivity will also increase. Okay, so reaction time A is the correct answer. And which modes of heat transfer can integrate microwave phenomena? Conduction, convection, radiation, or D, all of the above. Which is the mode of the transfer that can integrate microwave phenomena? Yeah, it is all of the above. Wait a second. Okay. Yeah, so actually conduction is the like convection is the one which in which the like water normally gets heated up, like the molecules go down, go up, and conduction is the mostly the metallic conductors, you know, right? In which the molecules transfer the energy to each, like to the next one, and it goes on. So in microwave actually all of these three processes happens. Okay, so and in all of these modes the heat transfer like can happen. Okay, so keeping this in mind, the reactors is been designed. Suppose a a chemical process which required certain amount of heat transfer, okay, or certain amount of heat, because there are endothermic reactions, there are exothermic reactions, all of kind are right. So they certain reactions require a certain amount of like energy to cross the barrier. So that's why microwave is something which provides heat, and in in all of these three processes, that is conduction, convection and radiation, like the heat transfer can be done. Okay, so going next is it is one actually hypothetical question. So like ionic liquids are salts that subsist as a liquid at a temperature under 100 degrees Celsius, and they are usually composed of a combination of organic cations and organic or inorganic anions. Okay, these are ionic liquids. Okay, then it can be mainly prepared using metathesis and acid base neutralization in small batches. These are only prepared in small batches, and this can be prepared using these two methods, metathesis and acid base neutralization. Now, ionic liquids are widely used in numerous applications due to their unique and advantageous physiochemical properties. Okay, this has these are widely used. So, considering the above statements, which of the following process instrument could possibly be used for the synthesis of ionic liquid? So, which of the following process we can possibly use for synthesizing the ionic liquids? Okay, follow the process intensification approach. Okay, so one is microreactor, other one is cell and tube heat exchanger, scrubbing tower, and D, none of the above. Yeah, macroreactor. As we know that these are only produced in small batches, okay, and these are very reactive also. So we need to like these have their own uniqueness and advantages, right? So if we want to synthesize them, then we need to use the microreactors for them, okay, so that we can get the required amount in small batches, okay, and particularly store them at a particular like at their ambient condition, so that these are very reactive, so that this doesn't react with anything. Okay, so the next one is, which one of the following can be drawn under the small to medium scale of process intensification? Plant site, plant, thin films and enterprise. Which one of the following can be drawn under the small to medium scale of process intensity? Small to medium scale. Think about it. Enterprise, what do you think? It is a small scale or it is a large scale? Plant, these are also big industries like plants, steel plants, or there are many more. For small to medium scale, which one can be picked? It is actually thin films. Okay, films are something that we can't like we can't produce it in a big in a large scale or large scale manner. So, and if we produce in large scale manner also, this won't be this won't give us much profit. Okay, so that's why if we want to like improvise the process intensification as a part of process intensification, then thin films are the one which shall be picked for our small or medium scale. We will uh, choose our like industry or our process. So as per our like budget, okay, and the requirement, obviously the requirement of thin films won't be very high, the demand won't be very high, so we won't require in huge excess of that it. Okay, so for small or medium scale of process intensification we need thin films will be the one which will be picked. Next is matching the like matching the principle with the example. Okay, so a there are four principles. uh, A is integration of unit operation, integration of function, integration of phenomena, and targeted enhancement of phenomena. Suppose which one is easy one? Suppose integration of function b. Okay, then which example will be correct for it? Suppose b is the one, integration of function. If we see integration of function, then will separation of carboxylic acid from wastewater via reactive extraction work? No, right? Uh, and will solid into product fluid in a membrane reactor? This is one phenomena, right? Solid into product fluid in a membrane reactor. Okay. Okay. Oh, Shreyas and Om, are you guys still there? Okay, sorry for the interruption. Okay. This was the one we were discussing, right? So integration of function, if we see, okay, 3 won't be there, 3 can't be there, and 1 also can't happen. So is it 2 or 4? No, 2 is actually correct, because if you see the integration of functions, then it is all about like conversion, contacting and mixing in a static mixture reactor. Okay, there is there are two types of reactors, right? One is static mixer, one is dynamic mixer, right? Okay, so based on functions of that, or based on the requirements, what we require, what we want to produce, the one we choose and that one we use. Okay, and if you see that is integration of phenomena, then phenomena is something that is the one example, that is solid into product fluid in a membrane reactor. Okay, this is one phenomena in which we are converting solid into the product fluid. Okay, and in a membrane reactor. Okay, and if you see targeted enhancement of phenomena. Okay, the targeted enhancement of phenomena, then there are two options left now, 3 and 4, that is separation of carboxylic acid from wastewater via reactive extraction and convective and diffusive heat and mass transfer phenomena in a static mixer. Which one? It is 4, convective and diffusive heat and mass transfer phenomena in a static mixer. It is targeting a particular phenomena and enhancing. Okay, so one is left with the 3, integration of operation, in which we are particularly focusing on the extraction unit. Okay, how we are going to like extract the carboxylic acid from the wastewater, and how we are going to separate. Okay, so we are particularly focusing on the separation unit or the extraction unit. Okay, so the correct answer is actually this one. Wait a second, I might have done some mistake here. Yeah, actually what I've said is correct, but what I have pointed out here is been wrong. So this will be the one that is the correct answer. That is unit operation means the separation under extraction, what I talked. Then the function, integration of function is the conversion, contacting and mixing. Then the integration of phenomena will be the solid into product fluid, and the target enhancement will be the convective and diffusive heat and mass transfer. Okay, that was a bit difficult, right? Fine. So the 15 question is the faster introduction of new products to market and reduction of capital cost is the example of what? Shreyas, has you typed your answer? That's fine, Shreyas. You will learn during the course of this whole course. Okay. So Om, will you give it a try? The faster introduction of new products to market and reduction of capital cost. Okay, and Shreyas. Okay, Shreyas has tried answering it. Let me see. Maybe a process strategy. Okay. Okay, but home is correct. It's actually a business strategy. So, like, business strategy is something like uh, when you like when we are introducing one market, it is newer, like one product, that is one newer product which was not there before to the market, and reducing is its capital cost so that we can attract many customers towards it. Okay, so it is actually one business strategy that we are introducing something, and simultaneously we are reducing the capital cost. Okay, it is not a process strategy, or it is not one environment strategy also. Okay. Next question is, the extensive developments in chemical and processing aspects can be achieved by which one of the following like options? A is improving remote control, decreasing the equipment size and production cost, C decreasing energy consumption, or D all of the above. Yeah, correct. So, in chemical and processing aspect, if you see, okay, if you want to achieve extensive development, okay, if you want to develop in extensive manner, so we need to do improve the remote control. Okay, so if you can control the plant or the whole system using remotes, then it will obviously be uh, obviously be better. Okay, uh, by sitting in one room or one control unit room, we can we can get the control over the whole system, over the whole hardware, and decreasing the equipment size and production cost. Obviously these are the things that one needs to keep in mind while designing. Okay, the equipment size, if it is big, then the plant size is like also increasing. Okay, and we need more control over it for to control a bigger equipment size than a smaller equipment size. If the equipment size will be smaller, then we can get more control over it, and the production cost we need to decrease. Simultaneously, the energy consumption, the energy it is consuming, the whole process. Okay, if we can decrease, then we can move towards the development. Okay, so the correct answer is all of the above. So what is the key strategy for any process intensification? Green, that is a green chemistry, or practicing traditional methods, involvement of unendurable processes, or narrower processing conditions. See, if you can exclude some options, let me make it more easier for you. See the D option, narrower processing conditions. It can't be a key strategy for process intensification, right? We can't narrow it down. Okay. uh, Involvement of unendurable processes. Yeah, green chemistry is the key strategy that we need to follow. The the less waste it will produce, so the less challenging it will be for us to separate our required product, right? And also how sustainable it is, how greener it is to the earth, to the planet. So we saw in the triple P triangle that it is profit, planet, and people. Okay, so we need to consider the fact of this green chemistry, and this is the key strategy for any process intensification. So next one is, which is not a domain based process intensification technique. It is absorption or stripping, demisting, solid liquid extraction, or adsorption. No, demisting is actually something in which vapor liquid. It is vapor liquid extractor people call. Okay, so it is one domain-based process intensification technique. Vapor liquid. You are quite close actually. Actually, the solid liquid extraction is the one which is not domain based. Other than that, absorption, adsorption, demisting, stripping, everything goes inside it. Okay, you can go through the. You have already seen Om, and Shreyas hasn't. Two like he has seen one lecture. He has started, so he'll see the other ones. Okay, you can go through them, and you can also ask your queries in the discussion forum also. Actually, there are like uh, if I can show you something that will be more better. Uh, Let me show you. This is fully visible, not this one. Let me show it in the bigger screen. Actually, in process intensification, all these things are included. That is methods, equipments. So, what are the equipments for carrying out chemical reactions? Okay, these have been listed. Equipments for operations not involving chemical reactions. Okay, the multifunctional reactors, the hybrid separation. So, like uh, in all these wide varieties, okay, so domain based one is actually it is one technique, okay, in which uh, like uh, like this is one technique which is used for process intensification, okay, in which all of these if I can show you one image of tea mixture, that might help. How shall I, let me see. Yeah, this is the one in which the feed inlet is here, in which demixture is something that is a liquid or vapor extractor. uh, it is it is told that vapor liquid separator, okay, so we give the feed here and this goes through these chambers, okay, and liquid is been separated here, and while vapor is been as it is been lighter, so it gets separated through the upper valve, that is a vapor outlet. So this is one domain based technique, okay, in which like this has been applied in the chemical process intensification, okay, and similarly there are other like absorption, adsorption, everything is been applied in the uh, as a technique for the chemical process intensification, okay. uh, Next going is, this is also something that you need to match. This this one is a bit difficult, okay. So it is giving that A is energy forms and transfer mechanisms, okay, and the process intensification techniques or technologies are gas, liquid, solid, trickle flow reactor, pulse operation of multiphase reaction, or microwave heating. Shreyas, you want to try? Okay, okay. Let me help Shreyas. If we see the microwave heating, okay, as a process, then what are we getting there? Okay, it is some form of energy, okay, which we are getting in the form of microwave, okay, and the energy, like, it is starting, like, as we start on the electricity, we are getting the energy, right, in the form of microwave. So there is some energy which is forming and which is getting transferred into some other form, and the whole process happens. Okay, so if we consider option A, that is energy forms and transfer mechanisms, then it will be microwave heating. Okay, so A is matched to 3. Now synergy integration of functions and steps, and next left is the timing of events and introducing dynamics. Okay, when dynamics is being considered, so you guys can consider the multiphase reactors. Okay, so C is been linked to 2, that is pulse operation of multiphase reactions, in which there is a particular time through which the, like, the reactants or the components will pass through the reactor. Okay, the timing of events is fixed, and introducing the dynamics, it is always flowing. So the components are been injected with the help of a pump through one end, and it will pass through the reactor within a particular time, and then will get out through the ejected valve. Okay, so C is been connected to 2, and uh, yeah, and B is been connected, the synergy integration of functions and steps, that is been connected to the trickle flow reactor. Okay, the correct one, so A to 3, and B to 1, and C to 2, right? So which one is the A 3, B 2, C 1? No, A 2, it's D, right? Yeah, so you guys got some idea, right, from the, like, how I solved it, right? It is microwave heating, so it is one energy that is been forming and that is getting transferred, right? And from the timing of the events and the dynamics, it, I got to connected with the multiphase reactions. Okay, so that's why it all happened. Okay, uh, next one is, which of the following techniques can be used for hybrid wastewater treatment? Sonochemical technique, or doped photocatalytic materials, or hydrodynamic aviation, use of polymeric hydrogel membrane for hybrid wastewater treatment. In any course, have you guys studied about this hybrid wastewater treatment or sewage treatment? Okay, there are actually plants or sewage plants, it is been called. So most of these industries are, like, producing huge amount of wastewater, right? Or hybrid wastewater is something, water, like, in which all sorts of impurities, like, which will be dissolved impurities, which is dissolved, and some are solids which won't be dissolved. Okay, and some are toxic gases also. So these are, like, all sorts of forms are mixed, so it will go to the sewage plants, and there are various platforms or various steps, so it will move step by step, and in each step one particular effluent or uh, impurity will be extracted. Okay, so we can use polymeric hydrogel membranes so that some like some impurities, okay, which are like every hydrogel membrane has a particular cutoff, right? It has one pore size. So the bigger the particles than the pore size, then it will not pass through the membrane, okay, and it will get separated. So in this way we can separate some impurities, okay. And we can use this sonochemical technique like the ultrasound waves, okay, for to clean some impurities, okay. And also we can use the some photocatalytic material or hydrodynamic caviation. In some photocatalytic material we can use to convert one thing into other, okay, so that we can easily separate that thing out from the wastewater, okay. So all these techniques can be used in the wastewater treatment, okay. You guys got some clarity? Okay. So actually these were all the questions, that the model questions kind of, you can tell. Okay. So this kind of questions, like sir, or like they might ask in the assignment of yours of this course. This was one previously run course and the assignment of that course. Okay. So the questions will be mostly similar. Some words, some will be here and there. Okay. But I'm stopping the presentation. Okay, and seeing if there is anything left. Okay, so Shreyas and Om, like I think Om, there are total 200 or some learners are enrolled, right? Yeah. Okay, I have checked, but I forgot the number. Yeah, so we were actually expecting a large number. We were actually thinking that Google in Gmeet we can actually host 100 max, right? Can't go beyond that. But it was quite good interacting session with you two. Only you two joined. Okay, hopefully we will, like, it was mostly theoretical, so and probably people have solved the might have solved the assignment one, so they might not be interested about it, okay. So in this way the courses will, like, the TA sessions will be run, okay. We will meet in the next session, okay, the next Sunday.